Hello again. Today we're going to be talking about one of my favorite equations, slope-intercept form, y equals mx plus b. First off, let's remind us what the letters all stand for. First off, the x and y are variables. That means they're missing numbers. They don't mean anything. We expect to see the y and the x in the problems. There won't be numbers in those spots. Now the m, there'll be a number in that spot. That makes it special. It is the slope, which we call rise over run, or change in y over change in x, sometimes referred to that way. And then that b number in the back, that's the y-intercept. Alright, so it's a very nice formula because it gives us everything we need to graph. We don't have to do anything besides just count things out. Alright, so let's take a look at the work. Alright, first off, we're going to be doing some problems where we have to write the slope-intercept form of an equation of a line that's already been drawn. So let's go through the steps one at a time. We'll do them both problems. First step, we're going to find that y-intercept. That's the b number. Right. So that b number in both of them. Find that first. Now on this one here, that intercept happens to be at 0. On number 2 here, that y-intercept happens to be at positive 1. All right, step 2. Before we can find the slope, we have to find another point on the graph so we can count. But I want to find a point that crosses at a corner. So for example, if I find this dot right there, that means I'd be counting up to and over like 2/3. I don't want to do that. I want to make sure that my dot is another spot that crosses on a corner. So when I count my rise and run, I'm counting with whole numbers. All right? So on the next one over here, it doesn't matter which way you go. You can go right, you can go left. It makes no difference. You're just looking for a spot where it looks like it crosses at a corner. I'd say that's the best corner that it hits on that one. A couple other ones that looked really, really close that you probably could have also used. All right, now that's step 3. Now we want to count out the rise and run. So back on number 1, we'd be counting up 3 spaces and to the right 1 space. And then we want to reduce that fraction down to the whole number 3. All right, number 2 over here, we'd be counting down 3 spaces and right 1, 2, 3, 4, 5 spaces, and that one does not reduce. Step 4, we want to write it now into this y equals mx plus b form equation. The y will always be there, but now we have a number to replace the m with. The x will always be there, and now we have a number to replace the b with, which was 0. So it's best in math if we don't write zeros, so I would say y equals 3x was the best equation there. Number 2, same idea. Y equals mx plus b. The m, we now know. It's this ugly fraction, negative 3/5. X is always there, and then the b number in this problem is a positive 1. So again, it's ugly looking, but it's not really all that much work other than finding a couple of dots and counting spaces between them. All right, now the other direction. Let's graph them ourselves. All right, step 1. We're going to start with the y-intercept. So in problem number 1 up here, that y-intercept happens to be negative 1. So I'm going to start there, my y-intercept. Problem number 2 over here, that y-intercept happens to be at positive 2. So on the y-axis, positive 2. It's always where we start. All right, step 2. We want to count the rise and run from the y-intercept. So starting at the y-intercept, we want to count out the rise and run. Now slope always has 2 things, 2 directions. All right, my slope on this first one is 1 over 4. But I could also make both of those numbers switch their plus and minuses. A negative divided by negative is a positive. And then I could count up 1 and right 4. Or I could have counted down 1 and left 4 for that second version of slope. We want to count both directions if possible. All right, now on number 2 over here, my slope is negative 1. You don't see it, but there's a 1 in front of that x. And I make it a fraction. And again, I've got the reverse where I switch the plus and minus for the top number and the bottom number. Those are equal fractions. If you don't understand that, I can show you something at the end here. So that means my slope could be this one. That's down 1 and right 1, down 1 and right 1. Or I could use this one, which is reversing it. Up 1, left 1, up 1, left 1. Right? Now again, if you're not understanding what I mean by those slopes being the same, when you write a negative fraction, there's 3 ways to write a negative fraction. you can write the negative sign out in front of the fraction. You can write the negative sign in the numerator of the fraction. Or you can write the negative sign in the denominator of the fraction. Those are all the fraction negative 3/4. All right, so again, when you're writing a fraction and it's negative, you can put that negative sign in all three places. But if you do this, not the same, because that actually equals positive 3/4. So we don't turn one negative sign into two negative signs, but we can put that one negative sign anywhere we want, out front, up top, in the bottom. All right, have a good day.